Dear students, today we'll start chapter 2, gaseous state. Gaseous state is one of the three states of matter. In this chapter, we are going to study these points, or you can say this is the syllabus for chapter 2. As we know, there are mainly three states of matter, that is solid, liquid, and gaseous state. And this classification of matter is based on the intermolecular forces of attraction present in it. So what is this intermolecular forces of attraction? The forces of attraction which holds the constituent particles or molecules together. As you can see in this picture, states of matter, that is solid, liquid, gases. So in case of solid, the molecules are very closely packed or closely held, or you can say the forces of attraction in case of solid is very high, and in case of liquids the molecules are loosely held as compared to solids. In case of liquids the forces of attraction is less, and in case of gases the molecules are far apart from each other and the forces of attraction in between these molecules is negligible. So on the basis of forces of attraction, the matter is classified mainly into three states, that is solid, liquid, and gases. We are going to study the kinetic theory of gases. Kinetic theory of gases attempts to explain the microscopic properties of a gas in terms of the motion of its molecules. The significance of the theory is that it helps in developing a correlation between the macroscopic properties and the microscopic phenomena. In simple words, you can say the kinetic theory of gases helps us to study the action of the molecules. Generally, the molecules of gases are always in motion and they tend to collide with each other and the walls of the container. So, the kinetic theory of gases was first proposed by Robert Hooke and was further developed by Maxwell, Boltzmann and Clausius between 1860s to 1880s. Kinetic theories are also available for solids as well as liquids, but here in this chapter we are dealing with the kinetic theory of gases only. So let us study the postulates of kinetic theory of gases, or you can say the assumptions of the kinetic theory of gases. So we will see one by one. Postulate number one is gas consists of a very large number of very small particles known as molecules. This point indicates that gases are composed of molecules. And the second postulate is that the molecules of same gas are identical. They have same mass, shape and size. Molecules of different gases differ in size and shape. So in first postulate we have seen that gas is made up of molecules, or it consists of small particles known as molecules, and these molecules of same gas are identical. Means suppose if we are having the oxygen gas, so all the molecules of oxygen are same in mass and shape and size, and if other gas is there, means nitrogen and hydrogen is there, so molecules of other gases are differ than the other one. So the molecules of same gas are identical. Now third assumption, gas molecules are in continuous motion. Their motion is random. Due to this random motion, they collide with each other and also on the walls of container. So as I have already told you that gaseous molecules are always in motion. So their motion is random, means not in one direction only, they are randomly moving, means they are randomly moving, and because of this random motion they collide on each other and also on the walls of containers. Fourth assumption, the collision between gaseous molecules and the walls of container is perfectly elastic. It means kinetic energy and momentum in such collision is conserved. Basically, it means the collision between gaseous molecule is elastic. Two types of collision is that, elastic and inelastic. So, in case of perfectly elastic collision, the kinetic energy is conserved, means energy of the, after collision, energy of the molecule is not destroyed, or you can say energy of the molecule, energy and mass of the molecule is not destroyed or not changed. So momentum and kinetic energy after collision is conserved. Next postulate, gas molecules travels in a straight line. The time interval of collision between any two gases molecule is very small. Means they are very fast they collide with each other. Next postulate, the effect of gravity on the motion of gas molecule is negligible. The gravity effect is negligible on the gaseous molecules. Now, next is a postulate. For an ideal gas, the actual volume of molecule is negligible in comparison with the total volume of the gas. It means that gaseous molecules are considered as point masses, and because of this, the actual volume of a gaseous molecule is negligible as compared to the total volume of the gas. And as the molecules strikes on the walls, they will create force on the wall, thus exerts pressure. And as we know, pressure is force per area. What it means? As molecules are in continuous motion, they are randomly moving, and because of this random motion, collision occurs between the gaseous molecules and the walls of the containers, and because of this collision, pressure is creating. The pressure is creating inside the container. So all these are the postulates of kinetic theory of gases. In our next lecture, we will discuss the kinetic gas equation.